So for this bell work, they have given us the radius and the height for this cylinder. So remember, a cylinder is created from two circles. That's why we have 2 times the formula for a area of a circle. And then it's also made up of one rectangle where the length is the circumference of the circle, 2 times pi times the radius, and then multiply that by the height. But they've given us those 2 values. So it's the same radius for both parts of the formula, which is showing as 7. And then the height that they gave us shows as 8 feet. So I replaced the height here with 8. The rest of the formula just stays the same, so I'm just going to fill this in. I have 2 parentheses pi times the 7 to the power of 2, close parentheses, plus new parentheses, 2 times pi times the radius 7, and then we'll multiply that by the height 8. So this is going to give us the area of the cylinder, the surface area of the cylinder, which at this point I'm just going to plug this into the calculator. So 2 times parentheses pi times 7 squared, close parentheses, plus parentheses, 2 times pi times 7, close parentheses, times 8. And when I push enter at this point, it tells me that the area of the cylinder is 210 pi. Now this is okay in terms of pi, but they did want the answer rounded to the nearest thousandth. So where my answer right now is in terms of pi, 210 pi, and this would be in square feet. I'm just going to push the double arrow button immediately above the enter button, and this will change it into a decimal for me. This will give me a new area for this cylinder. It's the same area, it's just shown in a different format. Decimal format, 659.7344573. So let's identify where the thousandth place value is. That's one place value to the right of the decimal, the 7, that's in the tenths, then the 3 in the hundredths, and then the 4 there in the thousandths. That's the one we're targeting. So I look immediately to its right and I see a 4. That would be the 10,000th place value. So the 4 in the 10,000th place value it's less than 5. So this tells us that the 4 the 4 in the thousandths place value stays the same. Okay, so this tells me that my new answer, rounded, will be 659.73, and then the 4 stays the same. Last thing I'll do on this one, I guess, is just label it, because we should label it. We're doing this by hand in square feet. That is my area of the cylinder rounded to the nearest thousandth. In today's lesson, we're going to see the answer is needing to be rounded to the nearest thousandth in some cases. But for some of the shapes we're going to be seeing, we may not. But our objective today is I can find the area of irregular shapes. And when we say irregular shapes, we're talking about shapes that are created from 2 or more shapes that have been assembled together. So what this means is that it's possible that you could see some kind of rectangle, and then on the edge of that rectangle, perhaps, is attached some kind of triangle, like this one. Of course, they have to give us the measurements for these, but that's what we mean by irregular shapes. It's possible that in the future classes, you may hear this as composite shapes. It doesn't really matter which one you call them. I believe on the assignment, though, it's going to call them irregular shapes. Take 15 seconds and copy this down. I can find the area of irregular shapes. You're welcome to copy the rest of this stuff, but this is the main objective here. Triangles are created by either cutting a rectangle or a parallelogram in half. Now, we're not talking about cutting it in half either vertically like this or horizontally this way, because if you did that, then you end up with just another rectangle. When I say I'm gonna cut this in half, what I'm gonna do is I'm gonna go from corner to corner. So I'm gonna choose these corners and cut this in half. What we see then is if you were to take the area of the original rectangle, then you would have taken the length and you would have multiplied it by the width. That would have been the area of that rectangle, right? But since I've cut that in half with the red line, this means that what we see here is now a triangle. And if we wanted the area of the triangle, which is what we're going to want in the first part of this lesson, is you gotta cut that in half. Now, notice the parallelogram here. It's possible that you could cut this from corner to corner as well and make this triangle right here. But it's possible to, instead of cut it that way, you could, if you wanted to, cut it from these other corners as well. All right, now the way that we look at parallelograms though is that you have some kind of base value here, and then you're given some kind of height. If they give you the height, they're gonna have to give you some kind of dashed or dotted line like this one, and then usually they'll show you that it's a 90-degree angle right here. That's how we know that this is the height. So this right here is considered the height of that parallelogram. So as it turns out though, with parallelograms, if you wanted the area, you have to take the base and multiply it by the height. But notice, I've cut this parallelogram in half this way. And so if I wanted the area of this triangle right here, and we'll pretend like I can stay in the lines, again, you've taken the parallelogram and cut it in half. So either one of these, notice it's just 1/2 times the value that they give us, which could be length or width, and then multiply by length or width. Just with the parallelogram, they're going to call this base times height. The one that we want for the triangle is this one, though. This is the area of a triangle. And we're going to be using base and height for those values. Kind of fit that on there. So yeah, the area of a triangle is just half the rectangle. That's it. Okay, cut it in half, and you see that you can create a triangle. So that's where this formula comes from. In a triangle, and we kind of showed on that last slide what happens if it's obtuse, but usually what they'll do is they'll set it up like this. They'll usually show the bottom right here, and we call this the base. Now, is the base always on the bottom? It is not. But the base always creates a 90-degree angle with the height. So what they'll do is they'll give you some kind of dashed or dotted line like this. And sometimes they'll even show the 90-degree angle right here. But this right here is the height of that triangle. Okay, and again, this is really just half of what would have been a parallelogram. So if we had inverted that triangle and attached it, you would have had a parallelogram like this. Of course, I really don't care about the parallelogram anymore. We need this formula, and you need to memorize this formula because it's not going to be given to you on any test or anything like that. So you got to memorize this. 1/2 times base times height is the area of a triangle. If by chance the triangle was obtuse, meaning it had one obtuse angle like this, you would treat this part as the base. But what they'll do is they'll still give you the height, but it's just on the outside of the triangle now. And so they'll even kind of extend this with a dashed line, but they'll have to show this 90-degree angle. Once again, that purple dashed line though is the height. It's just on the outside of the triangle, and that's okay. So it's important that you be able to find both these, because you may find obtuse triangles attached to other shapes in these irregular type shapes. But for the most part, really, we are looking at triangles like this. Now this triangle is really just half a rectangle, right? If I were to take this and pretend like my lines are straight, yeah, this is half a rectangle like this one, okay? So all I'm going to do is take my base, which I'm going to say is the bottom, this one at 6.6, and I replace my base in the formula with, well, 6.6. And then the height given here, 4.5, I replace my height with 4.5. All right, so the area of my triangle now is going to be, it's going to be 1/2 times the 6.6, and then multiply that by 4.5. This is just something that I can put directly into my calculator, so I will. And I'm using the fraction button, although you don't really have to. Some people prefer to use 0.5 and multiply, that's fine. 1/2 times 6.6 times 4.5, enter, and I get the area of my triangle there at 14.85. Didn't say to round this, so I'm not going to. And it said up here the units is in square feet. So that's the area of the triangle that we had started with in this area right here. So this triangle right here would be half a parallelogram. Like I said before, you could draw another, duplicate this triangle, but flip it upside down, and you'd have a parallelogram. You could put it here as well. I'm not going to worry about that one right now. It's just on this one, what we start with is the actual area of the triangle. Okay, so in these formula, we got area equals 1/2 times base times height. There's 3 unknowns. They have to give us 2, and then sometimes, like this one, we have to actually solve for the missing value. So the area is given as 10.98 square feet. And this will equal 1/2 times the base. Well, that's the value we're searching for, so I'm just going to use B for base. The height, though, is given here, this line right here, 3.6 feet. So I'm going to multiply that by 3.6. Now this is an equation that I must solve. And like we've done before, it's even 1/2 times B times 3.6. I can combine my like terms. It's just that right now I'm not looking at combining with addition. The operation that's being used is multiplication. So when I take 1/2 and multiply it by 3.6, I get 1.8. And that now is my new coefficient of B. 1.8 times B is going to equal 10.98. So now with one principle of equality, I can solve this thing simply by dividing both sides by the coefficient 1.8. Right, because that creates 1B, which is what we want. That's going to equal in my calculator 10.98 divided by 1.8, enter, and it tells me that the base length is 6.1. Now this is the base length, which means it's just in feet. It's not in square feet for this one. That right there is the actual base. Now, of course, if they had given us the base length, then we would have just plugged it directly into this formula, and we would have been done. But we can see, really, the calculator is still doing a lot of the heavy lifting. I did 1/2 times 3.6 in the calculator, and then I divided by 1.8 in the calculator. It's still doing all the work for me. Area of irregular or composite shapes. Like I said, irregular could be called composite. It just makes us math people look smarter than we actually are. But it says composite shapes are made by combining 2 or more shapes together. Sometimes you can have a rectangle attached to a triangle, attached to like a half circle, something like that. Sometimes it could be a triangle attached to a half circle, which would look more like a cone. And yeah, for the most part, since we're attaching circles onto flat-shaped figures, usually we have to attach those circles in half circles. So what we're going to do is find the area of each individual shape and add them all together. But even before we start looking at each individual shape, because this is more of a drill and kill type strategy, what we're going to do is stop and think, look at the shape, and really think about ways that we can manipulate it, even if we have to cut parts of the shape off to combine to make full other shapes. Okay, so yeah, some composite shapes can be split differently. And when we say split, it means I'm actually cutting off pieces and maybe combining with other parts of the irregular shape that's already given. And we'll see the strategy used, although you can use the direct approach of just finding each individual part and then adding them together. I'm still going to be doing that, but I'm going to be combining stuff as I go. So on this one, we got to find the area of the shape. And what I notice on this one is that I have a rectangle. And then over here, it's giving me, it's not a full circle, right? It's just a half circle. So I'm going to need to find the area of both. And I know the area of the rectangle is just length times width. And the area of my half circle, I'm going to take the area of what would be a full circle, pi times the radius to the power of 2. But I'm going to have to cut that in half because it's a half circle. Okay, so these are the two formulas that I'm going to be using together, and in the end, I'm going to be adding them together as well. Okay, so there's not really any nice way to do this one. So let's split this up though. Okay, so let's start with my rectangle. So we're going to take that rectangle, right? So I'll do it in red so that hopefully this makes a little bit more sense right here. And well, I can move it up. I can separate it, see, from the half circle. I really don't need to on this one because they've given us the length right here at 13, right? So I can go into my formula. I can say my length, I now know it to be 13. The problem that we see on this one with this being very new to us is what is the width on this one? Well, it's this full side length right here. The problem is we see that they've given us the radius of the circle, which is good. It just means that this length right here is 5, but that's half of that distance, which really is the diameter, which means this other part right here would be another 5. So altogether, this 5 and 5 would be a total of 10 units. So it's a 13 by 10 rectangle, meaning I can go into my formula and replace my width now with 10. Now I can calculate that. I can say, well, 13 times 10, I know is 130. In this case, square feet. I'm not going to worry about the label yet because I'm just going to label the answer. But then I notice on my half circle that the radius is already being shown as 5. So I don't need to figure out the radius again. I'm just going to go in. I'm going to take my radius and I'm going to replace it with 5. And then I'm just going to put this in the calculator to figure out what this is. All right, so that radius then is 5. So in my calculator, I've got pi times 5 to the power of 2, and then I'm dividing by 2. Whether you use the fraction button or not, I did not. I just used a direct division button, and it gave me this decimal. It's a pretty ugly decimal. At 39.26990817. That's what it's showing as half circle area. But it did say up here at the top that we want this rounded to the nearest tenths place. So that's what I'm going to do. I see that I got the 2 in the tenths place value. Immediately to the right of it is a 6. So the 6 in the hundredths place value is 5 or more. So this tells me that I need to add 1 to the 2 in the tenths place value. So let's do that. So I'm going to take my 2, I'm going to add 1, and then this becomes 39.3 square feet. So really, I'm taking the area of the rectangle, and I'm going to add to that the area of the half circle. Right, and I know the area of the rectangle was 130. The area of the half circle, rounded anyways, was 39.3. So yeah, adding these, it's really not too bad. I don't need a calculator for this one, so 0 plus 3 is 3, 0 plus 9 is 9, 3 plus 3 is 6. Drop the 1, and then we'll just label this in square feet. So that would be the total area of the figure that we started with, which was a rectangle, which had attached to it a half circle. If that's the case, then this one should be pretty, or fairly simple. We'll show why that is. Now, some students, like I said, we're getting used to this kind of stuff, and some students look at this and think, well, I don't really understand what shapes we're looking at here. I think the half circle is pretty obvious, but this other one, even this half circle may be obvious, but it's like, what the crap is this? What that is right there is it's a half circle. I'm sorry, it's a rectangle. That's better. So this one right here is actually a rectangle. Now I want to make that a full rectangle, right? So, and to do that, really, what I would need to do is to create a line right here at the edge. But I think some of you notice, and again, this is the importance of actually sitting down and analyzing this before you just start calculating away, which is fine. You can do it that way. But if you'll just think about this, you'll hopefully notice that if I were to take this half circle right here and then apply it into that missing space, that it fills that gap. And by doing that, it has removed the half circle part of this. Okay, so see how this now creates a full rectangle? And we know its dimensions. It's a 4 by 10 rectangle. Okay, so if I want the area, it's just length times width, 10 times 4. Well, that's gonna be 40. And yeah, up there it says square feet, so I'm writing the square feet a little bit differently, but that's our final answer on this one. Now going back, if you go back to the original figure, which had this, this one here on the edge, so let's take this away. What you'd have to do is you'd have to notice this is a rectangle. You still have to know this is a rectangle, but you take this half circle, find its area, which is the same as this half circle, and then find the area of the rectangle. You'd add these two together and then subtract this half circle. So this circle added, subtracting it away though, still just gives us a full rectangle. Now if that doesn't make sense, it's okay. It doesn't have to, because this is a fairly new concept for us. It is possible to take shapes, cut them up to make newer shapes that hopefully are a little bit more easier to calculate in terms of area, just like we did with this one. But again, since this is new, it may take you a little bit more time than what it's taking us to do this in class. But if you will stop and think about this, it will make a little bit more sense. And yeah, we really don't want you to be so robotic that you're just like, I'm just gonna start calculating away. I mean, it's fine, it works. It's just especially with this type of thing, you can figure out better ways. So I'm gonna work it the same way on this one. Notice they've only given us one of the values on this, and that's the side length right here, which means that inside I'm actually looking at a square. So let's see if I can, decent square right there. And yeah, that side length was 11, so I'm gonna need that. Now it is a square, which means this other side length is 11. That's important because I do want the area of the square. And I'll just find it right now because, well, it's not too bad. It's gonna be 11 times 11, which is the area of the square, 121. And yeah, you could label that right now if you wanted to, but I'm not worried about it. I know it's in square feet, but that at least right now takes care of the area of the square. And I'm shading now in red, just to acknowledge that we have actually found that area. Well, what about the rest of this? Like I said before, I'm looking to cut this up to make more regular shapes, not just irregular ones. So I'm going to start by taking the left, that's a half circle right there, and I'm going to combine it with the right half circle there. And what we notice when we combine these is that we get a full circle. But that was the left and right parts. I can do this the same way with the top. If I were to cut this off, and the bottom as well. If I were to cut this off and move it down here, I get another full circle. Okay, so the circular parts are going to create two full circles. And this is where we need the area of a circle formula. So this is the area of a circle. And this would just be one circle. That would be pi times the radius to the power of 2. Now you'll notice that they gave us the diameter of the circle, right? Because you could transpose that 11 down here, or the bottom 11, you could put it right here. So that's the diameter though, okay? So it is showing us a diameter that's 11, but what I really want is the radius. So to find my radius, I'm gonna take the diameter, which is 11, and I'm going to divide it by 2. Now I'm using division because I do want the decimal here. So it's showing us 5.5. So I'm going to take my radius in the formula and replace it with 5.5. So when I calculate this in the calculator, which the calculator is going to do it for me, pi times 5.5 to the power of 2, is going to give me the area as a decimal. And again, it's a pretty ugly decimal, but 95.0331, and then I got 4 sevens. So this would be in square feet. But remember that we actually have 2 full circles, so I still need to multiply this by 2. So 95.033177777 times 2, enter. And again, I'm just doing this on the calculator. That's showing us 190.066 3, and then I got 3 5s. Now that's what I have in green there. That's the area of 2 circles. Okay, but I'm going to round this to the nearest 10th place. Okay, so I got the 0 in the 10th place. The 6 just immediately to its right is 5 or more. So this means I need to add 1 to the 0 in the 10th place value, which is what I will now do. Add 1 there, which makes this now 190.1 in square feet. So now I've got the area of the square, I have the area of 2 circles, rounded in fact, which is showing 190.1. Well, all I got to do is add these 2 together. If it'll let me. Yeah, let's go ahead and add these together. But I'm going to use the calculator to do that. 121 plus 190.1. Enter. And I get 311.1. Yeah, this is where I will label it in square feet. Guess I'll just use some technology for that though. Yeah, this is going to be my final answer here. Which means that you should have the objective down here. I can find the area of irregular shapes. And if you feel pretty good about that, this assignment is going to run very well for you.